Really? Is that the best we can do? I said, hello, everybody. Hello. More like it, thank you. So, we're on. Right. I've only got 40 minutes, so I'm going to be whipping through this at something of a pace. I hope we're all in for a bit of an exciting ride. Not quite as exciting as those guys had, but nevertheless, I will do my best. So, I am from part of the UK called Shropshire. Apologies for the accent. There is nothing I can do about it. I'm afraid I'm stuck with it. If I say anything unintelligible at any point, that may be because I've just said something silly, or it might be my accent, in which case feel free to put your hand up and ask. As you can see, I'm from a county that is entirely landlocked, making me uniquely positioned to give a talk on the Titanic. And in fact, this is the biggest boat I have ever been on in my life. It's the little ferry that takes you between Liverpool and the Isle of Man. So I'm sure I'm completely qualified to host this talk. So, first off, a couple of quick definitions of terms. Machine learning, that is what we are talking about. AI, machine learning, some people get them a little bit sort of muddled. To make it clear, machine learning is a subset of AI. That is, all machine learning is AI, but not all AI is machine learning. Below that, there is also deep learning. I'm not touching that today, so this little red band represents the scope of our talk. The term machine learning was coined by this gentleman back in the 1950s, and he actually used it, amongst other things, to make a machine learning algorithm which played the game of drafts, also known as checkers. It's been around for quite a while, and these are its uses. So, image recognition, that's a pretty common one. Translation, fraud detection, the banks. If you've ever had that thing where the bank has suddenly blocked your card and you need to phone them up to get it unstuck, that's probably because a machine learning algorithm has stepped in and thought that it's detected fraud. Making recommendations, things like on Amazon or whatever, where it's suggesting, based on what you have ordered in the past, I think you would quite like this. Funnily enough, I have written a book, and it keeps recommending me that I read my book. I love the email that I get saying, hey, Simon, we found a book we think you'd be interested in. And I have to say, yeah, I am. I think about it quite a lot, actually. But I already own quite a few copies. And detecting medical conditions, things like it's looking at X-rays and the like. That is a common use, again, of ML. So it's used for prediction. For predicting, well, not exactly the future, but how something is meant to be categorized or valued in some form. This is the system. With machine learning, you start with a set of training data, that is historical data. You run that through some sort of process by which you transform raw data from history into a model, which can then be used in correlation with a new set of data to create a prediction. This prediction will always be numeric, although the way it's actually then rendered further may or may not be. But that is ultimately what you're getting. And this brings us to Kaggle. So, Kaggle is probably one of the best of the sites, if not the best site out there for learning machine learning. So if you're interested in it yourself, this is probably the best place to go. And their so-called hello world of machine learning is the Titanic challenge. The Titanic challenge is this. Take the passenger manifest of the Titanic, and then, based on a set of data, which is the training data, where they survived or not is filled in, take another set of data where it's not filled in, and make a prediction for each one, did they survive or not, based purely on the details in the passenger manifest. That is the challenge. And this is the Titanic. Has everybody heard of the RMS Titanic? I'm guessing there's a chance you may have heard of it. It is one of the most famous boats in history. This is it off on its maiden and only voyage. It's actually one of a set of ships of the Olympic class, the first being the Olympic, built in 1911, the Titanic itself in 1912, and the Britannic in 1914, which actually never sailed as a passenger vessel because it was pre-opted in a sort of a war-type thing that kind of happened at the time, and ended up as a medical vessel, as a floating hospital, basically. Olympic, on the other hand, continued service up until, I think, the 1930s, and bits of it are now used in restaurants around the UK if you want to go and see what it might have been like to be in the posh lounges of the Titanic, or rather the Olympic. This is it being constructed in Belfast in, I think, something like 1911, 1912. And its intended route was to start in Southampton in the south of the United Kingdom, going to New York in the United States of America. Apparently, we have these posh guys, according to a documentary I once saw, at the top. Billy Zane and his friends apparently sailed on the Titanic. He must have aged very well. But then these were the first-class guys up at the top of the boat, and then down at the bottom of the boat, apparently it's all Irish folk musicians and probably hay bales and penny whistles and all of those sorts of cliches that are mostly not true. And it also carried post, which is why it's the RMS Titanic, the Royal Mail Ship Titanic, because it also was carrying post and had its own postal office on board the ship for sorting the post ready to deliver in New York. It had 7 decks with the posh lounges and so on at the top, and the upper decks are the ones that the first and second class passengers would have been sitting on. The third class passengers were down here on the lower deck, basically cattle class. And this is the route, or intended route, of the Titanic, starting at Southampton on the 10th of April, and then a few hours later arriving at Cherbourg in France, before moving on to Queenstown, it's not called that anymore for some reason, in Ireland, and thus on to the Atlantic, where it kind of came a cropper a little bit on the way to New York. In fact, it met this guy. This is an iceberg. In fact, this is one of the few pictures of the iceberg that struck the Titanic. There are at least 2 or 3, but this is the best one. And from what we can gather from witnesses, it struck the iceberg and broke into 2 pieces and sank to the bottom of the sea. Some passengers managed to get aboard lifeboats such as this, but of course, relatively few managed to do that. And thus it has sat on the bed of the ocean for all of this time. Apparently it's likely to be there for about another 30, 40 years, at which point it will have just rusted to pieces, and which is why there's a flurry of investigative work being done into the boat at the moment to capture this. There have been films based on this, varying in quality from these relatively high-profile attempts to depict it somewhat accurately, down to these guys, which are somewhat less attempting to match reality, especially the animated one with the talking mice and the rapping dog. I wish I were joking, but that's true. Don't watch that one, trust me. So, our data. Moving on to our Titanic data challenge. This is the data that we've got. These are the data items. I say passenger manifest, it's actually based on various sources which have been compiled. The actual Titanic data passenger manifest has been lost. But this is sort of the best fit as we can for the various bits of data. So we've got things like what class of passenger you were, your sex, how many people you're traveling with, that is the number of siblings and spouses, parents and children, how much did you pay, cabin number, and where did you embark, that sort of thing. These are the data items we've got to use to try and make our decision on whether someone survived or not. And that's what it looks like in raw CSV. I've applied some color here to try and make it a little bit more readable, but you get the idea. It's just a plain CSV. You get 2 CSVs, a training set and a test set. This is the training set, because survived is over there in the blue column on the far left. 1 or 0. If you want to actually send this onto Kaggle, you pack this into a CSV and it'll give you a score. Right, there were a couple of celebrities, in case you were curious, on the Titanic. This is Margaret Brown, who was a socialite, and that's basically her job. But she was very interesting because she refused to get on the lifeboat for a very long time because she insisted on helping all of the other passengers, despite herself being a first-class passenger, and only got onto the boat when she was told she absolutely had to and there was no choice. And once on a lifeboat number 6 as it happened, she insisted they had to go back to pick up more survivors from the water. And when the guy in charge of the boat told her no, she told him that they were doing it or he was joining them in the water. They went back and picked up more people. And upon being rescued by the Carpathia later, she formed a committee of first-class passengers to look after the third. She has been depicted in pretty much every film of the Titanic ever made, and even has a musical based on her. She was known at the time as Maggie to her friends, but the press nicknamed her the unsinkable Molly Brown, if we've ever heard of her. She is in pretty much every film ever, so. And this lady was a Hollywood star. Dorothy Gibson. She made the first film ever based on the Titanic because she was herself a survivor of it. And this is her in a publicity photo wearing the actual clothes she was pulled out of the water in. This film, I'm afraid, is lost to posterity, along with every other film she ever made, sadly. They were lost in a fire some time ago. So moving on to some actual data analysis, I'm starting off by using Jupyter Notebooks. Now, Jupyter Notebooks is not a .NET technology. It's based in Python, but it is probably one of the best ways to quickly try out a whole load of stuff if you want to try a load of ideas. These are the plugins I used: Pandas, NumPy, they're for processing data and reforming it, and Matplotlib and Seaborn are used for grading graphs. I used it in VS Code, and VS Code has a Jupyter Notebooks plugin. It works just fine. It's really easy. You hardly have to know any Python, but it is not probably the sort of thing I'd use in production myself, but it's great for just trying out some ideas fast. So you can have a bit of an eyeball at the data, see what's doing, and then sort of take that knowledge and apply it across then to .NET. You can quickly and easily use a function called describe to get things like means, standard deviations, that sort of thing. Notice that there are some fields missing here, things like ticket number and cabin number. That's because everything has to be numeric. Basically, fundamentally, for something to be processed by machine learning, it has to be numeric, and that's the only way. So those are currently missing from this because it's unable to process them as numbers. So this is why you have to feed in functions like this. These functions I wrote convert various categorical bits of data into numeric. So passenger cabin number, for example, I chose the first letter A, B, C, D, E, F, G, and then converted them to numbers 1, 2, 3, 4, 5. I did the same with where did you embark and sex. Now, a quick note on sex. The only two sexes represented in this data are male and female. That is not me making any sort of a comment. I'm aware that we're living in a more enlightened age where there are more than two, and it's probably not entirely a categorical value, and that is completely fine and acceptable. But this data is from 1912. There was nobody on board the Titanic who openly was acknowledged as anything other than male or female. That is just a historical artifact. If I were writing this now, I'd probably use a different data structure for that particular property. So a couple of kinds of charts. This is a scatter chart. So this is charting how many family members have you got versus your age and whether you survived or not, purple being survived and yellow being not. So you can kind of see there's some sort of bits of pattern there. There's some blobs where you've got only one color here, there, or around, so you can get an idea of whether that's useful. This is age and density, that is how many people of each age. And the two graphs, the brownish one is survived and the blue one is not. We can see there's a bit of a bump here, which suggests that in a very young people probably had an elevated chance of survival compared to someone in, say, their mid to late 30s, I think that would be, where there's a significantly lower chance of survival as compared. So that may be significant with use of age. Passenger class. What class of ticket? So if you had a second class ticket, then you've got a better than even chance of survival. First class, still quite a lot. Third class, oh dear. So if you bought a cheap ticket or you were not a very wealthy person, then your chances of survival were less. I'd like to say things have changed, but... And where did you embark? This is Southampton, Cherbourg, and Queensland. As we can see, with Queensland and Cherbourg, your chances are pretty good, but with Southampton, not so much. I can only speculate on what that means. My guess, and it is a guess, is that perhaps being the first lot of people embarked at Southampton, perhaps they were put lower in the boat for convenience and the rest were put higher up. I think there's a fairly common theory that the higher up in the boat that you were based, the better your chances of survival were. So that's a theory, but I don't actually know if it holds water. That was not an intentional pun, but that's quite good. So can I take that? Right, letter number. Now, this looks like we found a whole big wump of pattern, but we haven't. That's a 0 on the left-hand side there. 0 is I don't know. Basically, most of the cabin numbers are unknown. The original manifest is missing. We don't actually know who was in. And it makes it look like everyone who wasn't unknown has a really good chance of survival. And I suspect that that's a case of survivor's bias. All of the people who survived probably were asked which cabin were you in, and most of them probably remembered. There are certain people who weren't asked because they weren't capable of answering. That's why they're all in 0. And that's why we've got a bias towards non-survival in that category. This is a heat map, and this is one of the most useful types of graph you can throw up. This is every field mapped against every other field, and its statistical percentage of significance mapping the two. These are a value which is between -1 and 1. -1 meaning perfect correlation. As one doubles, the other doubles. -1 being perfect inverse correlation. As one doubles, the other halves. A 0 meaning absolutely no correlation, they're random. And the deeper the color in this graph, the more statistically significant everything is. There's a couple of interesting points. There's a total family maps really closely with how many siblings or how many parents. Well, of course it does, but that's irrelevant. Fare maps against passenger class, because of course it does. The higher class of cabin you had, the more you paid. That makes sense. But the bits that we're really interested in are what maps against survived. Of course, survived maps one-to-one with survived because it's itself. But beyond that, we have got a 54% correlation with sex. That is, are you male or female? There is the old law of the sea, women and children first, and this appears to have been followed on Titanic. So being female is a strong statistical significant indicator of survival. What else have we got? Passenger class, minus 34%, meaning that as class goes up, so survival rate goes down, which is not as counterintuitive as it sounds, because we have mapped first class to 1, which is numerically lower than 3. So that is basically the higher the class in our terms, the better your chances of survival, which makes complete sense. I'm not saying it's nice, but it makes sense. And embarked, where did you embark? A minus 13% correlation, and cabin number, basically the same sort of a thing, 30% correlation. So the higher up the boat there were, the better your chances of survival. Right, moving into ML.NET. This is a relatively little-known Microsoft project, but it is a very powerful one and a very cool one, because it allows you to quickly throw together a machine learning application and use it in your .NET code without very much work necessarily. So I'll show you first how I do it quickly. There's a wizard that you can run, and basically from the wizard, you choose which sort of ML project you want. I'm using data classification, which is, I've got this set of pots. Here's a new data item. Which pot does it go in? I only have 2 pots, as it happens, survived or didn't, but you can go more complicated than that. We've got value prediction, which is like I've got a range of values that are possible predicted. You can do image recognition, text classification. There's a lot you can do with this. It's a very powerful project. And we'll show you how it's done. Here we go. Add a new machine learning model. I don't like... Ooh, can someone turn the sound off? Sorry about that. I didn't realize we had some sound on this. Doesn't matter. It's just me typing. There's nothing embarrassing going on. Right. And give it the CSV file. This is my CSV file of training data. I do not like live demos. I've seen enough of them go wrong to never want to do a single one. Process the data, bang, it's processed the data, it's managed to put it into a tabular form. Now we have to do some advanced data options. I'll go into these in a little more detail later, but we've got 3 different columns here: purpose, data type, and categorical or not. So each of the data items has to be configured on these. It does make a best guess at what the correct configuration is for your data. I found that it is questionable at best whether it gets these right, and that's because it doesn't really understand your data. It's just making a guess based on roughly what it looks like. Okay, and that should about do it. Press save, and go to the next page, which is actually to run the training algorithm. I'm going to give it 20 seconds here. You can give it as long as you like. There is a bit of an art, as I understand it, to picking the right amount of training, and bang, it's going to start processing this. So you notice there's a lot of bad values in there. I'll get to that in a bit. But it's looking through all the data and running all of these through various different algorithms. It's got lots of machine learning algorithms based in it, and it's trying each one to see which gives it the best results. As it happens, it's choosing fast tree over, whatever that is. I don't really know, and I don't really need to know. But the more time you give it, usually the more model types it will try. Training complete. And that is actually it. So what it generates is a set of CS files, which I don't know if anyone can see there. They basically sit in your code file, in your code base, and they can be used just as normal C#. This is not a million miles away from database first EF, where you have your database and you create a model and then you interact with it in C# code. Basically the same sort of idea, except we're not going away to a database anymore. This is a compiled model. All you have to do is give it the new data item and it will make a prediction. It's actually super duper fast because the work, the training has already been done. Once compiled, machine learning models are really quite efficient. Okay, reading my CSV like this, just using CSV parser. This is for the test data. And then this is how I use it. So each Titanic, each machine learning model gives me an input class and an output class. I have to convert my CSV row into the standard input class it's made, which is Titanic auto.model input is the type, and feed it in using a function called predict. and that's it. It will then give me back a copy of the data plus a few bits of metadata which represent the prediction and how confident it is in that prediction. It is that easy. And that's how I'd use it to quick answer lookup. So on the advanced data options, as you can see, I've put a set here of choices. And what do each of these mean? Well, supported data item first. There are only 4 data types that are supported. That is string, float, bool, and date time, and that is all you can do. All numerics must be floats. I don't know why. I would hazard a guess it's because everything's dealing with probabilities in this, and that's probably got something to do with it. But those are the only 4. So all numeric values make them float. Most other things need to be a string. My survived, in this case, is a bool. I don't have any date times. Categorical data. So this is a tick box. Is it categorical or not? So what are these? Categorical data. Title, Mr., Mrs., and so on. Again, in these more enlightened days, there are more, but this is historical data, so we only have historical titles to work with. Species, cat, dog. You could be a cat or a dog. You cannot be both. You could be human or politician. You cannot be both. You get the idea. Color, red, blue, orange. That's categorical data, as opposed to continuous data. Age. Human age varies between 0 and a theoretical maximum of 120. One person is alleged to have beaten the 120, but there is some dispute over that. Price of a sandwich and color. Once again, color is interesting because color is both categorical and continuous, depending on how you define it. And that is why it is always important when looking at statistics to understand how you define your terms. Don't get me started. I could rant for an hour on that. Right, purposes. Feature, label, ignore. Feature means I will use this and it is predictive. Label means that this is the thing I want you to predict. And ignore, well, yeah, ignore. Pretty much what it does. And there's my choices. So, for example, I have made passenger ID an ignore. Passenger ID is irrelevant. It has no relevance whatsoever to what happened historically. It's a modern ID assigned. Passenger class is a feature. It is a single because it's numeric, and I've made it categorical. And ticket fare is feature and single, and it is continuous, so I've not ticked. You get the idea. So do this for everything. And these are my stages. Refine the data, fill in the missing data, train my model, and then make a prediction. You don't do this every time. What you would do is do the first 3 stages in advance, and then actually just do the 4th one in production. The 4th one is, there's my data. So what can we squeeze out of this in terms of extra information? Well, title is one, because if you look at the names here, they're all in this form, like Bonnell, Miss Elizabeth, and so on. Her name isn't really very useful to us at this point, but her title is. Her title might give us some indication of age, of social status, or any number of things. So that's worth pulling out and turning into a virtual field. There are some rare fields like these, like Lady Duff Gordon, Don Manuel, I'm not sure how you say that. My personal favorite, Major Archibald Willingham Butt. I am not child enough to laugh at a... yes, I totally am childish enough to laugh at a very funny name. Sorry, Major Butt. So this is the code I use to trim out just the title. I've simplified it a little bit into Miss, Mr., Mrs., Master, which is an old term which is mostly not used anymore for a young boy. Military, I've kind of simplified into military. Doctor and Reverend, relatively common, believe it or not. And then everything else just rare. There is only 1 or 2 of each of those titles at all. So. This is the cabin numbers that survived. Well, the number tells us nothing, but the letter tells us which deck they were on. So let's try pulling just the deck out by literally pulling the first number. You do get a couple of complicated, weird ones like this, but still, first letter basically does it. And that's, yeah, easy. And that gets me 77.751% accurate. Now, I've hardly done anything. This is very little effort. A couple of bits of C# and an automatically generated model, and 77.751 accurate. That's not terrible. Not terrible at all. I am going to see how much more I can go with this. Now, I know people have gone up to 90% accurate. I haven't quite gotten there, but we can still go a bit further than that. So let's have a look at filling in missing data. This is using Pandas to pull out the missing items. So we've got 177 missing ages. I think we've got enough data that we can fairly accurately predict missing ages. So that's all right. There are 2 missing embarked values. To be honest, when you've only got that few and it doesn't make that much of a difference, just fill in with the most common value, that is the mode, will do. Now, there are 687 missing cabins. There are only 800 items of training data, so that is so significant a number that I'm just going to drop cabin because it's not useful. There's too much missing data. I don't even think I've got enough to train it on how to fill in the missing bits. So, bang, let's not bother. So fill in missing data, that's the first two items, the mode for embarked and so on, that's easy. And what I'm going to do is make another training model for filling in the missing ages. With this time, I'm going to give it a value prediction rather than a category prediction, and try and pass it the same data and see if I can fill in the missing ages. And as you can see, not terrible. Not terrible at all. Some of them are pretty close. Eleanor Dwyer there, 22 to 22.4, that's fine. Some of them are a bit off. But broadly speaking, they seem to kind of roughly float somewhere around the expected age. So we've not done a terrible... I went on the Titanic Wikipedia, by the way, to check these answers. So my process is, now, load the data, refine the data, train my age predictor, fill in the missing ages, train my survival predictor, and then predict survival. So what is our new score looking like? It's now 77.99. A little better. Let's see if I can do a little better than that. So the next step I did was start on a manual version. So you can see how the model-based approach works. Let's have a look at the manual version where I literally hand code everything. So I have to first create a set of classes, by the way, to represent the input and output, just the same as the automatic one, except I do it. And I have to apply a few bits of metadata, like column name, and maybe load column if you're loading from a CSV. That's not too difficult. So select out my CSV data, convert it into one of these new custom classes just to be input to the ML class. Create some custom mappings, because what we're going to do is create a pipeline. If you see up there, this is a pipeline. The pipeline is the transformation of raw data into prediction. Okay, and I have to define the pipeline one at a time by appending items of transformation onto the pipeline, and it will create the whole process for me in code. So custom mappings are where I want to create new virtual fields based on one or more existing fields, and for that you need to make a pair of classes, one for the representing the parameters you want to use as inputs, and then the new output fields. And I'm guessing it uses something like reflection or something under the surface, and I suspect it uses its own data class, which probably uses key value pairs or something like that to represent. I don't know, but this works just fine. So I can then make a custom class which takes in name and converts it into the title. And over here I made one that takes family and number of siblings and number of parents and converts it into virtual fields like number of family and whether you traveled alone as a Boolean or not. And this is what my custom classes look like. So input for the family transformation looks like that. Input for output looks like that. And there's also some standard transformations we can apply. One hot encoding is how you re-encode categorical data from being a string into numeric, which the thing can understand. So that's just a standard transformation. So I'm giving it the value of sex, embarked, and title, and I'm telling it to one hot encode them, which means take them, they are strings, turn them into a numeric value that the machine learning process can understand. And I'm also applying some normalization to fair and age to see if that gives me any better results. And then I can also append a transformation, which is a standard replace missing values transformation, saying take embarked and fill it in with the mean. So I don't need to bother finding the mean myself. This will do it. And there are tons of these. It is a very rich library full of transformations, so it's worth digging pretty deep. And the custom transformation system gives you an awful lot of stuff you can do anyway. And then, so this is my final transformation, is to append all the things I want to use into a feature called features. And that consists of age, class, number of siblings, embarked, sex, fair, and title. I played around a lot, and this was the best combination I could find so far. And then I'm using a trainer called Fast Forest. There are a lot of trainers. I basically tried every single trainer and then saw what the results were like until I found the best result, and it turned out to be Fast Forest. And then do a fit, which gives me a model, which is an iTransformer type. The iTransformer I can then store, and it's the iTransformer I will use to make predictions. Okay, and this is the process for actually getting a prediction. Convert from CSV into the input type. Load from enumerable, that turns my data from an enumerable into a data frame, which is what's used internally within it. Transform, meaning make my prediction. There is a function you can call off a prediction called preview, which gives you a sort of a fairly loose data structure, which allows you to look at all of the data that's coming back, and you can decide which of these data items to map into or not in your output class. There's a lot of metadata that you can decide to capture or not, but most of it isn't really very useful. and then create an enumerable from my prediction, which gives me back my result. Now, as it happens, I was just I was taking the whole set and then converting it all in one go. If you want to make one, then basically do the same thing. Take one, put it in an enumerable, convert it into an output enumerable, just take the first row, and there you go. And that will give me my predictions. So I was 77.99. Using that, 78.94. Well, it's only a percent or so higher, but that is still quite a lot. And believe it or not, with this challenge, it does seem to take quite a lot of work to get each percentage higher. And this is as high as I've gone now. Now, if anybody wants to have a little go, I see we've got 10 minutes left, this is it. If anyone wants to have a go, you can try right now and find out whether you survived or not. So this will take you to a link which I have hosted in Azure, which will give you the option to put your own details in, and then it will give you a customized result based on whether you survived or not using historical data. Now, once again, you can only choose male and female. I can only apologize for this. This is an artifact of historical data. If you do not feel that you fit into either of those, that is a completely valid opinion. But in this case, I would suggest that maybe you invent a character who can sail on your virtual Titanic or something like that, because unfortunately, the data is historical and will not support anything other than two genders. That's just the way it is. A more modern system would probably be different. Has everyone had a go to scan this? Yeah. Okay. While you're doing that, I shall push on a little bit, but I'll be interested to see what everyone's results are. So, other things I can be doing. Ensemble learning. This is basically use a whole load of different models, get the results from all of them, and then kind of read the room to make a decision based on multiple algorithms as to which you go for. I can cluster ages into groups. That's something I'm working on at the moment. We can cluster ages and sexes into groups. That is, make sort of virtual groups using multiple fields. The gender surname model. This is a model based on take the gender and also the surname. That is, grouping people into families, which apparently is a very powerful predictor, and I will be interested to see how I can do that. But the coding is going to be quite complicated and have a couple of stages in it. The woman-child group model is something similar, but you're also taking into account things like nannies and so on. And gradient boosting, which is a hardcore mathematical idea, which is taking the various fields and then boosting them through a mathematical process, which makes them a little bit more mathematically significant. So, okay, I think, has everyone had a go? Okay, put your hand up if you survived. Well, that's more than I expected, in all honesty. But not many of you, which is probably about right. And everyone else, I'm assuming, died? You poor things. But hopefully you noticed that was pretty fast. Now, that is actually based in Azure in the west of the United Kingdom, so it's not based locally, but hopefully you should have still gotten a pretty fast result out of it. And that is the thing. Machine learning models, once compiled, are really fast, because they're basically just binary trees under the surface, something like it. So it is just going ping, 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 ping through the tree and getting your result fast. It's a pretty fast and efficient thing to use in production. But most of the trick is compiling the model in the first place, which requires the understanding of your data, which is where all of this comes in. This, if anyone is interested, is my source code. I've hosted it on GitHub, so I'm kind of interested to see how much further I can go with this thing, because yeah, I've spent a week or two working on this, and I've gotten some fairly reasonable results. But as I understand it from people who are far more clued into data science than I am, what I've got is basically entry-level results. It's not terrible, it's not the worst, but significantly better results are possible. I've seen some people claim that they've gotten over 90%, and I'm curious to see how they've got that, because it does occur to me that you're certainly never going to get 100%. I've seen people claim that too, and I don't believe them at all, because there are weird statistical flukes in there. I mean, this is based on a real event that happened, not just on a pure data-driven process. So if someone was in a first-class cabin and had a fabulously wealthy cabin with a view at the top, and their lifeboat was waiting for them, but they accidentally tripped on the stairs on the way, and then they missed the boat, well, that sort of thing is not going to be factored in to a machine learning algorithm, because statistically they should have survived. So there is going to be a point at which this is not capable of predicting random foolish events like that. Or what if someone was a third-class cabin member who, as it just so happened when the evacuation started, was on the top having a little walk around the deck? Once again, our model is not going to predict something like that. I believe there were stowaways on board the Titanic. There's no way those guys could be predicted. So I'm dubious of anyone that ever claims 100% accuracy in almost anything. But nevertheless, I believe you can get pretty high up. So, how much time did I spend on this? Well, trying things and back and forth. To be honest, I spent about a day or so swearing at Azure as I tried to get that to host. But I probably spent more time, in fairness, writing the natty little app you've just tried than I did the actual machine learning system. The machine learning bit was the easy bit, as is always the case. Writing, there's probably a whole load more. Please don't play too hard with the Azure app, by the way. I'm sure it's got bugs. I'm sure there's all sorts of ways that you could cause me no end of damage. But and also, it stores no data, so don't worry. All of your data there's no data storage. There's a static class, basically, that sits in the constructor of the machine learning predictor. And the first time somebody for the day logs on, which I did earlier just to try and encourage it on its way, it trains the model at that point and then holds that static class in memory. And then everyone else who comes in, they just get checked against the model that was pre-built about an hour ago. So that's... Oh, I have another question. Oh, 2 questions. Yeah. Mm. You can put it in. Well, okay. So how much time did it take me to build this? Actually, not all that much time. It probably took me a couple of evenings worth of work. And some of that was... Oh. Oh, okay. Right. Well, the one you're looking at, I actually gave it about 300 seconds. Now, from what I understand, there is an art rather than a science to how long you give it. And part of that, because there is a danger that if you give it too long, it overtrains, meaning it becomes too hyper-specific to the training data. So, as I understand it, you're probably best off trying a few things. But generally, with ML.NET at least, the more time you give it, the more algorithms and configurations it tries out. So my feeling on ML.NET is, in this case, it's probably worth giving it more time so it can try more things. Although the more time I give it, it always seems eventually to focus on some sort of fast forest algorithm, which appears, at least in the case of Titanic, appears to be about the best choice. There are a whole load of other algorithms under there. So otherwise, I just try every single one personally. With the manual one, I just tried a whole load of different ones. I made my data structure such that I could just literally try 5 different algorithms and get the result. I found a copy of the answers to the machine learning challenge. That's not because I wanted to cheat, because where's the fun in that? It was because I wanted to try a lot of ideas in rapid succession, and I didn't want to have to keep going to Kaggle to find out what my score was. I could just write a unit test, which would give me my percentage of accuracy. And I compared it against Kaggle, and I've got it right. So it means I can rapidly try ideas out, which is what I want. And what are we doing? 2 minutes. Okay. So wrapping up, and I can still take a question in a moment if anyone has any. If anyone is interested, I've also written a book. This is not a data science book. This is a book on my other passion subject, which is functional programming and C#. I wrote this for O'Reilly. This URL will give you a month or so free on O'Reilly's platform. If anyone would like to go, you can read whatsoever you like. But, you know, I would be quite happy if you would read my book as well. It is a very silly book, I should warn you, because I wrote it, and that's how I write books. I've also written a couple of training courses for O'Reilly on how to learn C# and stuff in the first place. So if anyone is really, for some reason, enjoying the sound of my voice, and I can't imagine why, you can listen to an awful lot of it on O'Reilly right now. And if anyone wants to learn more about machine learning and statistics, these are 2 most excellent books that I have gotten a great deal of information from. That is Statistics by Witt, I'm not quite sure how you say it, same surname, published by Wiley. This is an excellent book on statistics. And the 100-page machine learning book, this is available for free, which is always a good price online, but I own a physical copy because I do actually take these sort of things and read them in bed, because that's the sort of thing I do, because I'm a nerd. And does anyone have any further questions as the Titanic sails away? And this is actually the last confirmed photo of the Titanic as it left on its final journey. So does anybody have any questions now? Going once, going twice. Okay, well, thank you very much.